Okay, thank you very much for attending this session on Retrieval Augmented Generation, or RAG, techniques for Salesforce, which is basically a means to creating intelligent chatbots that integrate with Salesforce. But first, I want to thank our hosts, Mark Good and Ian Gott at Elements Cloud. It takes a considerable amount of effort to put on a production like this: the conference, the website, the promoting, the social posts, the coordinating all the session speakers. I mean, it is a lot of work, and not only have they pulled it off for this, but they did it. It seems like just yesterday in August of 2023. So thank you very much to everyone at Cloud Elements and Mark Good for pulling this together. So a quick recap on so how did we get to this conversation about RAG? Well, last August, without RAG, we were chatting with an individual record and individual files. So on the opportunity, we walk through what we call Flow GPT, and this is the ability to do some quoting and create some rules around quotes. And we did some work around File GPT. So we upload some PDFs and images, and then through a GPT prompt, we can interact with these documents. So this led to some obvious questions, namely, how do I chat with many records, or can I chat with the entire Salesforce org, or can I chat with many files in a library? And so that is why basically the RAG type of technique evolved. So we'll talk about what is RAG. We'll talk about why is RAG needed, when to use it. There's some trade-offs when you would want to continue doing some inline injection of some prompts versus RAG. We'll talk about some Salesforce-specific retrieval techniques, generating some inline queries, interacting with Apex versus vector storage type of techniques. There's the obvious security limits and challenges with RAG. We're going to get into those in pretty good depth. Some real-world use cases, some customers that are actually using it. And we'll talk about careers in AI and where RAG is going to be applicable. And if there's time, I'll try to answer some questions either during or towards the end. Okay, quick background. I'm Mike Leach, CEO and founder of iDialogue, which you can find on the App Exchange. We're focused pretty exclusively on software and services around generative content and AI. We started initially with a lot of PDF generation type solutions and have evolved into AI-driven content. So in this presentation, you're actually going to see a combination of many pre-integrated APIs and AIs. Obviously, the Salesforce APIs, conversational AIs provided by iDialogue, OpenAI and Azure for the large language model embeddings and completions, Amazon Web Services for our optical character recognition and vector database, and for image generation, Midjourney, and DALL-E. So what is RAG? I actually posed this question to DALL-E to create an image, and so create an image visualization that supports the RAG architecture, user query being converted to an embedding, and it actually is pretty good. We have two humanoid-like entities, the entity on the left being the user, what they are saying. The text is going through this transformation through what is presumably like a vector database to an embedding format to this bot on the right-hand side. So we have this dialogue going back and forth, and the intermedium for humans to interact with the machines is vectors and embeddings. And so we're going to talk a lot about that in this module. First off, hopefully we can do as much as we can live. OpenAI is sometimes up or down. If you see any error messages, just have to kind of give our offerings to the AI gods as we start off here. I've learned to insert this slide just because of an incident exactly 1 week ago where OpenAI was down due to some denial of service or other things going on. Okay, you're probably already using RAG techniques if you've built a GPT, or maybe in some other sessions you've seen them refer to knowledge, which is the ability to upload a PDF file to a GPT. And what's actually happening in the background is GPT is converting that PDF, doing some sort of text extraction, and it's indexing the text of that document within a vector database. And similar for actions, these are means to retrieval. So if you want your GPT to go out and book flights or do something very kind of dynamic, we have this controller middleware now mechanism called actions, which is a type of retrieval. And within Salesforce, same concepts. In fact, we're using the exact same API. Instead of actions, we call them skills. And instead of conversation starters, we have prompts. And for our knowledge, we're just using related list of files in Salesforce. And really what makes this possible is, this AI as a service. We're entering into a new era of computing where you no longer have to build your own data centers, your own data clouds. You don't have to crunch your own AI. You actually can just do what Salesforce did with software as a service. Now we have AI as a service, and it's directly accessible. So every time OpenAI releases a new feature, Azure, Bing, iDialogue, and thousands of other companies all get the same features. We're all kind of sharing the same operating system. And that's really what this is. ChatGPT and OpenAI and a lot of other LLMs emerging are basically the next generation operating system. And if we look at the characteristics of an operating system, we have some hardware, GPU, NVIDIA is just exploding. So we need something to manage that interface between the users and the hardware. Resource management, file I/O, security, moderation, checking toxicity, networking capabilities. I mean, these are all what you would expect from an operating system. You wouldn't want to go out and build your own Windows or build your own Mac OS or build your own Linux today. And so we're starting to see, similarly in the AI space, you wouldn't build a lot of these capabilities on your own, bottom up. There are companies that have been focusing on this. AI has been building their infrastructure for about 7 or 8 years now. And so we're building applications. Logically, what comes next after an operating system are the applications and AI applications. So in kind of version 1 of this operating system, GPT-3, we have a user coming in talking to a GPT conversation stack. And it warms up and initializes with a grounding prompt. There's a user message. It goes through and what would be kind of the controller tier. And by the way, I'm borrowing kind of a full stack developer. We currently kind of refer to development in 3 tiers, a model view controller. So the new view going forward is this conversational AI is the chat experience. The controller here is looking at the intent of the user. There's some moderation controls, and at that point, if it triggers any moderation, it will actually just kick back. And then it forwards the message to where a lot of the magic is happening in a large language model. I won't rehash too much of what an LLM. We spent the entire GPT dreaming last August. You can go back and view those, where we spent pretty much the entire conference focusing on an LLM. But in an enterprise application, there's not a lot we can do with that. If I pull up a case record here, and I have what would be considered like a GPT-3 model, and I can ask it, hey, summarize this case, and it just comes back with, hey, sure, I'm happy to help. Tell me some details about the case. And so it really has no context about the case, actually. It has no, like if I do sentiment of the customer, doesn't really have any idea of who the customer is. If I ask it to troubleshoot this case. So every single time I'm initiating a query here, it's going out to the public LLM and it's just returning whatever it can find, whatever is relevant. And so that's also kind of referred to as hallucinating because it doesn't really have any grounding context. Okay, so then we advanced to GPT 3.5. And so let's take a look at what changed here. I'll highlight above, we've gone from a 4K token memory limit to 16K. So if we go back to the previous slide, a 4K limit, you can probably get about 3,000 words can fit within a conversation before that triggers truncation and compression. But now with 3.5, we can fit anywhere between 5 and 10,000 words maybe. And so suddenly we had this ability, and what we demonstrated in previous GPT Dream-In is via flows, in real time on initialization of a chatbot, we can extract some information from Salesforce, we can pull in some data from files, and we can put that into a grounding prompt and some contextual data. And so you can fit many types of files actually into this kind of conversational stack. So by the time a user message comes in and it gets passed to the middleware here, now this has the luxury of, okay, the intent is relative to a case and some files. There's some moderation. And this was also the very first kind of introduction of what they called tools, which eventually was renamed to, it was called functions, renamed to tooling, and in GPT they're called actions. So another new feature here, fine tunings. This is a very advanced feature, but it gave primarily developers the ability to upload these very large key value pairs, kind of simulated conversations that say every time a user asks this, then this is an expected response. And it's a form of training actually. And so you would not need to necessarily inject any sort of files or tone or mission information every time there is a chat, because that would be built into the LLM. But it's still available today, and it's available. So all this information comes in and it comes back as an assistant response. And so if we go back to our case here, kind of our 3.5 bot. So I'm asking this model to summarize the case, and now it's actually aware of the case. If I go over to the details tab, I can confirm, there's a subject and description, and it knows the account and the contact. So now I can actually chat with this, and it would know things like, what is the customer sentiment, and so what's happening here is we're actually executing a flow during initialization. It's getting the case, it's describing all the case fields, it's describing the account, the contact, case comments, emails, and because it's a flow, there's really no limit to the amount of information you can pull into it. The only criteria is at the very end, we have to assign that to what's called a system prompt. And that system prompt comes back and it gets injected into the context. And that's only done once, so this is kind of an initialization. So every time I chat with this bot, we're not rerunning the flow. I can ask this bot to troubleshoot and resolve this case, but we've not initialized this with an FAQ or frequently asked questions. So now actually it's just going out to the open LLM, and whether or not this is hallucinating or a close enough answer, it's kind of a mixture of the two. It's not really the answer we wanted to give specific for their product, but it's pretty close. So then this year, or actually within the last 6 months or so, we've had this evolution of GPT-4 with 128 token memory limit. And you can fit about 50 to 70,000 words within the context of this kind of window. And for reference, the average novel has about 70,000 to 120,000 words. So think of your favorite book, fiction or otherwise. You can pretty much fit the entire contents of that book within a 128K token memory. And you can start chatting against it. So we use this technique quite often in legal documents, contracts. We can load multiple documents into this memory window and chat with them. However, it's a lot of tokens. There's a lot more costs. So what else has kind of changed here, highlighted? So over to the right, or the far right, you can see that we have ERP, financial enterprise resource planning data. This is starting to look a little bit more like an enterprise architecture. We have the ability to pull in more data. And we've introduced what's called a vector database, which is kind of pre-caching the data that a chatbot would be allowed to interact with. And this could be CRM data, files, financials. Within a GPT, on ChatGPT, when you upload knowledge to a PDF, basically that's exactly what's happening here. It's a file going into a vector database. And then 1, 2, and 3 are the R, A, and G. So we have a retrieval function router is now able to search this vector database and retrieve just a subset of the relevant content. It's able to augment the conversation. So it's taking the grounding prompt, context, user message, and it's adding an extra layer of augmentation of what it retrieved from the vector database. It's going to the large language model, which is then the G, which is generative, is returning that back to the user. So an example of that, we can go to kind of the next evolution of this chatbot, summarize this case. And again, we executed the flow. Summarize this case with bullets. We can say using markdown table format, customer sentiment analysis, misspellings and all, but it's semantic, so it figures that out. So now I can actually kind of go next level, because in this model I've actually added a file, and I've pulled that in as one of the skills for this model. So I'm going to say ask it to troubleshoot and resolve this case. So now it's doing a search. It says I have successfully troubleshooted and resolved. The recommended oil type is, and we get back the answer we're expecting. Synthetic oil should be changed. And I can say, this looks good. Update the case. And this model also has within its function router, the ability to update. So over here I have a field called AI suggested resolution. And if I update this case now, it's updated the resolution. I can go over to my customer portal page or room. I have Edna, the contact here, and a link. Send her a link. I'm going to refresh the page. So now we actually have some suggested resolution. So the customer actually sees the resolution, and the customer can chat with their own version of a model. This is a different model, but some overlap. And so maybe they're happy with the oil type, but they have a question about, what gas type to use. And this comes back with 87 octane. So let's kind of take a look behind the hood and what happened here. I'll go into the dialogue tab. And for this case, let's load the transcript. So we started a transcript. A model was loaded. Some tooling was defined. So remember, we have a function router here. And, these are basically actions. And so update case resolution, search case FAQ. These are a couple skills that were given to this particular model. The flow ran, so we initialized with a system prompt. We're telling it your mission and tone, act as a helpful bot. We're dumping out the case details, the account details, contact details. So we're really just kind of building a big document here before we even get to the user query. So the first thing the user types is summarize this case. And by the time that the LLM is seeing this, it has the luxury of everything before it at its disposal to answer the question. So we say summarize this case. It doesn't need to invoke any tooling because it has it all in its grounding prompt and its memory. So sure, here you go. Then we played around with the formatting, bullets, markdown table. Customer sentiment analysis was actually wrong. It called search case FAQ. So this is a good example of, I kind of like the defects to be shown in these demos, because that's why you need to have certificates like GPT specialist and to know how to do these prompts. I mean, what would have been more proper is, what is the sentiment of the customer. So, ask this in a way that, so it knows it's frustrating, not sure if the instructions are on page 2. So it's getting that from one of the case comments. And so, yeah, that was kind of user error on my part, gave it a bad prompt. Then we got into, okay, troubleshoot and resolve the case. Then it decided, okay, now I want to search. I'm going to go into the vector database, search the case FAQ. I'm going to pass in a query. What oil type is recommended? How often should it be changed? And out of this vector database, which could have dozens, hundreds, or thousands of PDFs, product manuals, operators manuals, bulletins, guides, it found just 1 or 2 paragraphs within all those documents that were relevant to the question. And it says, well, I have successfully troubleshooted the case and resolved it. I actually didn't notice this. It called 2 functions. It decided that, okay, it was going to do the case FAQ and then update the record. So in the next prompt here, I literally typed update case, and that was actually redundant because in the previous step, it had decided to do that. And it looks correct. So we got the oil type. So let's actually verify that's correct. So I'm going to go into our AI models here, and let's take a look at this is the Ice Cube model. And over here to the right, so these are the 2 actions. It has the ability to update the case on its own, and it has the ability to do an FAQ knowledge source. So I'm going to look at the FAQ knowledge. And what I've done is chosen the semantic search primitive type here. So this has, it knows its primitive function is semantic search. It's getting its knowledge from attached files, and its search source is Retrieval Augmented. So rather than injecting the file inline into the prompt stack, it's actually doing the RAG technique, grabbing the top 2 results and putting it into the response. Now it says get all your knowledge from attached files. So if I scroll up here, I have 1 attached file, support generator support fact. One of these must be related to oil, above 32 Fahrenheit, use SA 30. Just looking for some key numbers here. Changed after the first 20 or 30 hours, then 100. And if we look at our bot, changed after the first 20 or 30, then every 100. So yeah, there you go. We have just the right paragraph from this document being injected into the chat thread. So RAG, if we break down this transcript, we have that retrieval. We're doing the augmentation. And finally, we're passing to the LLM to combine everything and generate a response. All right, let's talk a second about future state. Where is this going? Because AI is moving extremely fast. And so what's changed here? What can we expect? So what I'm highlighting here, draw your attention to the 1 million token barrier. So GPT-4 is about 128K, 128,000. Claude is about 200K. Very suitable to loading many documents, the entire source code base. But what is possible with 1 million and then beyond going into 10 million? So for those of you who bought your first PC back in the 90s, go back to your earliest computer and how much memory you had in that computer and how much, you thought that, oh, this is amazing. I'm never going to need more than 640K. Well, that's what's going on with this new era of operating systems. AI is an operating system as we're getting more and more memory, and we have more and more ability to push some content into this conversation stack. So 1 million tokens, that's about 500,000 plus words. I think that's more than the English dictionary. Grounding prompts can be tons of data. So we still have these flow mechanisms. We still have initialization. We're pulling it in. What else has changed here? So in the lower right-hand corner, now we have past chat history. That is being injected into the vector database as we move along. I don't know how many people saw the announcement from ChatGPT or OpenAI just about a week ago. And they have a new feature, which is long memory, which is once you enable it and you click on new conversation, it has access to your past conversations. So this intent and function router controller layer, now as the user message comes in, it has this decision where it's like, okay, maybe the user is referring to something in a past conversation. I'm going to go into the vector database and look for that. So from a sci-fi perspective, I mean, the impact here is, someone born in the year 2030 with their smartphone could interact with a single conversation, a single AI for their entire life in everything from their homework assignments and chat and social media posts and messages, even getting into videos, selfies. Everything is going into their own vector kind of database. And when their purchases, consumer behavior, and when they interact with the AI, it has the benefit of going back into the past. Which could be, there's probably already a Black Mirror episode about that, but that's kind of the future state of where we're going. All right, some of the trade-offs. So inline context, if you actually, when we get to the 1 million token barrier, it's just the path of least resistance. I mean, let's be honest, you can just be lazy as a developer because you can just dump all of your information into the context buffer. And that is faster development. There's no actions necessarily. There's no functions to define. It's really ideal for loading many related files. In fact, the legal industry is just being turned upside down, being reinvented at the moment. Paralegals can sit there and write a prompt, pull up past case studies, all client files. But it is slower. I mean, the more tokens you have, the more it's going to cost. And at the moment, this operating system is largely, you're paying by the token, or you're paying by the thousands of tokens. And so with Wirth's law, that's kind of coming into effect, is that even as the GPUs get faster, the models get more efficient, what we're doing on the software side and the apps is we're just using that hardware as fast as it becomes available. Whereas with a RAG technique as a trade-off, there's a little bit of extra dev time, but it's going to run a little bit faster. At least we're not going to be at initialization. We're not loading as much. We're using lots of smaller functions. We're maybe pulling out 1 or 2 paragraphs instead of dumping an entire document in. And it's going to be cheaper, substantially cheaper from a token perspective because we're just being more efficient with the tokens. Now, there is a performance trade-off with vector searches because there is some latency in vector searches. Okay, if we focus just on functions that interact with Salesforce, traditionally, the traditional definition of RAG uses a vector database, but I'm using RAG kind of loosely here. Any sort of retrieval mechanism that is augmenting the user prompt can be qualified as RAG. So we can use RAG techniques to generate SQL, SQL, SOQL, SOQL, tomato, SOSL, however you want to pronounce those. Any sort of structured query language. GPT is just brilliant at structured query languages, and we'll play with that in a bit here. Flow, you can execute flows. Not only auto launch flows that are just data in and out, but you can actually, within a chat, just have it load a screen flow. Like what is the most relevant screen flow at this point? And a human has already determined that, okay, this is for CPQ, this is a particular screen flow I want executed. And Apex is certainly not going anywhere. There's a lot of existing Apex, but now we have the ability to invoke Apex dynamically. We can give AI some hints as to what exists at the controller level of Apex, and it can invoke it. We have both unstructured and structured. Those are basically, unstructured would be files. Structured would be working against Salesforce records, and comprehensive techniques, which would be combining, you would use this in account-based sales. You can combine everything related to account, like every opportunity case, contact, task, emails, and put all that into a very comprehensive record or a snapshot, and then put that on the vector database. Okay, let's see if this query will let us play with it here. So go into this AI assistant, data sage, and this is a very simple model. It can only do two things. It can describe metadata, which is kind of an expensive operation. It can take 5 seconds or more. And it can generate basically SOQL queries against whatever metadata it's aware of. So if I want to ensure it's generating good queries, the first thing I need to do is actually ground it within this chat thread so that it's aware of the actual fields on the account. So now I can ask it questions like, which accounts are in the energy industry? And it comes back with some accounts. It generated a query, and I can say, add, extend the query to include billing state, type, rating. And if I want to learn about the contacts, for example, as long as I'm not expecting custom fields, this is a little bit of a risk, but I can just ask, like, I could say list all contacts associated with the energy industry accounts. Okay, that's pretty good. And what I'll probably do is I'll say include email, and phone. Okay, so there we go. And let's open up our, let's go back in the dialogues here. Describe the account object. And let's look at this transcript and see what it did in the background. So we initialized, we have a model, the tooling. So I mentioned it really just has two capabilities. It can describe object and it can query records. So there's a couple actions or a couple skills on this object, and this is all it can do. Not much of a system prompt. We're just saying, hey, you're helpful. You might be asked to describe or select, so we're kind of giving it a hint there. We describe the account, and the function router determined that go off and call the describe account object with parameter object name. We get this metadata, we've itemized it. So now we get into the actual query. So we said, which accounts are in the energy industry? And the AI skill determined that, okay, call the query records function with the arguments select ID name from account where industry equals energy. And we got back some legitimate records here. We extended that query with billing state, type, and rating. And then I normally, with a progressive kind of prompting, I would have had it describe contact. But I kind of tested what the LLM understood of just what's out there on the Salesforce public APIs for contacts. So it knows, for example, a contact has a ID and name. It also knows it has email and phone. So it made the correct assumptions there, but if I really wanted to lock this down and ensure there was no hallucinating, I would have put a few shot prompts in the grounding prompt. Okay, so probably the number one request from a lot of our users after we launched FileGPT was the request to search entire libraries. And in this case, we have a library of aircraft technical publications. And with each one of these aircraft, we have service bulletins. And when you work in the maintenance, repair, and overhaul space for these aircraft, it's really important, kind of like you get a recall for a car. I mean, you want to make sure that safety first, that you're kept abreast with all this information. You can search for it at any time. So if I go in here, I'm going to do a search for all publications that are related to urgent or emergency service bulletins related to safety. That's going to a vector database of all the documents, and it's come back with, well, the first one here, yeah, that looks like that could be safety related. A few more, fuel quantity limits, so getting some summaries. And so then I can just go ahead and open up any of these documents. And I could just get to work, load this up on an iPad. I have diagrams for the aircraft. I know exactly what bolt it is they want me to fix. Yeah, if anyone saw the Alaska Airlines losing its left door incident, I mean, this is where workflows get lost in the documentation, and the databases just get pretty vast and huge. And AI is really going to be the only way we can sift and get through all this information safely. And one thing I like to reemphasize with a vector database is it's not indexing English. In fact, it's in a numeric kind of format. And so what I usually like to do is have like an English to other language translation available. And I want to do the exact same search, but in Chinese. And when it goes to vectorize it, it's actually looking for the semantic. It's looking for the meaning of emergency, urgent, safety. And if that's important to the AI, then it's going to go in and match. And it's pretty close. I have emergency procedures, caps inspection and correction. I got that bolt adjustment. So it's pretty close. It's not 100%. Let's go to the transcript. Let's see what actually happened there. We initialized with a simple model. It has one semantic search capability, a skill called search publications. Very light grounding. And then I just gave it a search. Urgent or emergency service bulletins related to safety. It did the correct invocation. It knows the right action. It passed in a query. And it went through all of those PDFs. And a keyword search in many situations just won't be sufficient. And in fact, a lot of people who work on the front lines, a lot of their expertise is in like doing an effective Google search. It's just knowing how to do a search. With semantic search, I won't say we can be lazy, but we can be we can be pretty loose. We can just try to describe what it is we're looking for, and the AI will actually go figure it out. So same query here in Chinese. Search publications, passed in a query, got back very similar documents. Sales enablement, if I had to pick one product for a Salesforce admin to focus on, sales enablement is a really kind of easy one, simply because we're constantly trying to document our changes every time we do a deployment. And we want to bring our users up to speed. If we launch a new feature, like here's a new process for generating a quote. And really what you want to do is give them text and pictures, animated videos on how to do certain tasks. So in this case, we built up a series of content for our own quote room product. And I can ask it questions like, how can I be notified when a customer views my quote? So it's doing a semantic search. It's going into actually a custom record called content, and it's come back, well, to monitor the quote activity, do this, click on this tab. So I go over here, click on the tab, and okay, sure enough, this is how I get that information that the customer actually viewed my quote. So if I open up the content tab, really simple, they're just custom records. So as a Salesforce admin, you can click on new, and it's a rich text field in the editor. So you create a new record, you type in like a how-to, maybe upload a picture, then in the details, kind of seed it like you would with any GPT action or a function. You're telling it, hey, these are some possible keywords that somebody might ask about. And that's really, really effective, especially when sales users have access to that information right on the page layout. Now, I've been opening up the dialogue tab a lot in the transcripts. And for compliance purposes, this also is kind of a necessary feature. If you've ever called to a call center and they say, hey, this might be recorded, in any sort of industry where there's compliance and you need to record what it is or what advice you're giving a client or a chat bot is giving a customer, we have to be recording that at all times. I mean, that can be turned on and off. It's highly configurable. Another reason we do this is for retrospective analysis. Is you want to periodically go in and see how the chatbots are behaving. And eventually that actually gets too overwhelming. You just manually cannot keep up with every single dialogue, every single conversational thread. So new tooling will need to be invented. We have some APIs to get to those threads. And, we'll actually use AI to audit AI. So, the right functions and actions being called. So that's the dialogue as a custom object in the transcripts. Now, vector databases they're totally secure from a point of view, and that there's no training on them, and that data doesn't get out. But the biggest issue with vector databases is anything within that vector is potentially accessible to the user who's interacting with it. And you really want to think of vectors a lot in the same way that you would partition your customer portal or communities, which is you have records and you have an internal view, and on a case you might have internal comments, and you have information that's only internal to a Salesforce user. And within the portal, when they log in and look at a case, there's information they can only see: the subject, the description, case comments, maybe the priority. And so we want to make sure that we're using different rules. And what we do within RAG is we have different, what we call vector spaces. And so we would create a vector space for internal usage on the case, and we would create a vector space for external usage. There really is no equivalent of like field level security. A vector is a document. You can think of it if you're making a customer brochure accessible on your website as a PDF, and you put that PDF in a directory that's accessible to your customers, you made a decision that that's external public content, and everything in that document is external. Now, within a room context, because this is running a flow that at a very granular level, it's a combination of vectors and inline text. So within inline, it has the case, the customer, and that is secure, and that's running in its own room container. But if the customer is to do a query against the owner's manuals or guides or FAQs, that is going into a vector database. So this is what a vector looks like. It's a lot of numbers, basically. The user's query that comes in actually also gets turned into what's called an embedding, the exact same width, and it looks very similar. And then it goes through cosine similarity and other types of matching for the highest probability. And that's how we get our top end results back. And then any raw text associated with that embedding is then used in the augmentation. So we've been really fortunate. Some of our earliest customers have kind of gone along with us for the journey as we've rolled out some of these new features, and they've adopted them. We've had some net new use cases in aviation, healthcare, tech, legal, nonprofits. It was kind of a last minute decision to just do this presentation. But in future GPT Dream-In, we're actually going to bring in customers and talk about these solutions live. So, but in aviation, we've had some success going into aviation logs, taking pictures of the cockpit, analyzing the type of GPS, the serial numbers, flight agents and booking. We're embedded in some other ISV as an OEM kind of API. So with Aviate now, they've bundled our solution as part of their Part 135, managing fleets of aircraft. This is a really interesting area, kind of the future of CPQ, is that we're bundling a chat bot with a product configuration workspace, and they communicate to each other through events. Each one raises an event. If a customer clicks on something within a product configuration, the chat bot is notified. In this case, Lux, she'll say something, "Oh, it's a great selection. Let me generate that quote for you." Or conversely, you could type something in the chatbot, and Lux can, the chatbot will raise an event, and that propagates back down to anything consuming the event and updating the product configuration. Healthcare, again, going back to aircraft safety, healthcare is another one where potential drug interactions, risk with prescriptions. You're never really going to lose human in the loop for anything healthcare related in the lives and safety of people. But just to have that backstop, that 24/7 process, just doing these checks for you in prescriptions, diagnosis. RAG is it's almost a must-have, because even with a 1 million token limit, there's no way you can fit the body of knowledge of the healthcare industry into a GPT. And so this is a very high utilizer of RAG techniques. Nonprofits, donor relationship management, chatbots. Internally, we have volunteer onboarding. These bots are imbued with the mission of the founders. They can generate very personalized emails to the donors. We have a lot more to kind of share around the nonprofit space. And as a 111 foundation partner, we have dozens of nonprofits using our software on just the donation letter alone. And then we have a few of them getting into the GPT space. So I'll talk about some of the current limits. I talked about this manual transcript review. As you're scaling up, there's just a very high volume of conversations taking on, and there's no need to really read transcripts, but we do need to make sure there's some alignment. Are these models behaving as we expect? Are the right skills being called? So we'll have to kind of develop the tools to help scale in that area. Vector databases are still evolving. We've tried a few off-the-shelf vector databases. It turns out that Salesforce objects and this combination of SOSL and SOCL, and there's a right mix for querying very large volumes of data. And so we continue to we expect our next iteration on that's going to get about 10x faster. I won't get into all these details. One area I will focus on is DevOps, which is the development and sandbox and deployment to production, and the iterative process of these models. And the custom objects in Salesforce are a proxy actually to our API. So it's very easy to serialize them and move them around. The mechanisms for doing that through, say, a change set or what we're working on, we actually end up just serializing the whole model to a static resource. And we'll be looking at other DevOps tools as well to fit into their workflow and process, and so that we're adapting to their process. But at the same time, I think we're going to present like an iDialogue methodology for DevOps, and that'll be a certification, kind of top down, because there's some lessons learned that we can convey and train and get people, pretty quickly into a healthy DevOps kind of process. So let's talk a bit about careers, jobs, certifications. This is really on everyone's mind. I hope you saw in my presentation at no time was there really a threat to taking anyone's jobs. If anything, what this is like a new skill like Excel or word processing. It's just helping people in their existing jobs do it better and faster. I hope I've imposed that AI used in industries where it's focused on safety, human health, healthcare, diagnosis. There's a lot of very, very productive use cases where we really should just be getting this out there today. It's amazing tool. We have generated so much information, documents that we necessarily need AI now just to know what we don't know. So 100% of the workforce in every industry will be impacted. And I mean that impacted in that whether they're on a phone or in their job. AI at some point will be assisting them, and it'll be good for people to know how to prompt. Even in K through 12 schools, it seems like weekly I'm seeing new press releases where some country has given every student their own ChatGPT homework instructor, and so they're embracing it. They're not fighting it. We've kind of gone through the teacher-student phase, and while that's not completely resolved, now we're going through this employer-employee. Okay, this tool is here. The genie's out of the bottle. How are we going to deal with this? And so AI is a career. So if 100% of people will benefit from learning to use it as a skill, maybe 10% of the workforce will actually have a job that's directly engineering and working with AI. And so some job descriptions I think will go unchanged, like a business analyst, for example, is a perfect existing role where their job is to analyze the business. And, they think very abstractly, and they think in set theory and joins and bringing information together. And so a GPT interface is a very logical and conducive interface for them. You want to pursue the GPT specialist type of certifications and get these proficiencies in developing these prompts. AI model and skill builder, it's going to be very valuable to make these determinations as to what goes into the grounding prompt, prompt engineering flow builder, what goes into the functions, what goes into the RAG. An AI architect is going to be that person that's going to experiment with the balance between grounding, inline, RAG, fine-tuning. So it's an operating system. You have memory, you have CPU, you have file I/O. And, fortunately this time around, I think when the internet came out, we spent a good 3 to 5 years with kind of this model view approach. We had a browser, and then we had a back end, and we put all the code either in the browser like JavaScript, or we put it all on the back end. And then we finally kind of this conclusion, okay, some middleware, this third component, is useful as the controller. And fortunately, I think with AI as an operating system today, we're seeing immediately that RAG is kind of that middleware. It's like, okay, we have a view, we have data, we need to broker the back and forth, and this retrieval augmentation is a pretty effective technique. Let's just start kind of building on that today. In terms of putting an actual revenue on it, I'm pretty conservative, but what we do know is that NVIDIA is like, in terms of market valuation, is the number 3 or number 4 largest company in the world today. AI chip revenue over the next 5 years is going to be about $80 billion. And, if you're being really conservative, you could say the halo of that ecosystem of rolling this out, building the applications, is 10 or 20 times that. But easily this is going to be in the trillions, $3 to $5 trillion globally across all of these jobs very soon. So some frequently asked questions. Can an entire org be vectorized? Yeah, I can show you this kind of offline. Am I required to create a vector DB? No, there's no creation of a vector database. There's more of an abstraction of a vector space, which you just define kind of like a file system structure. And that's it. If you want to learn more, you can go out to our website, www.idialogue.app. Search for us on the App Exchange. And again, thank you very, very much to our hosts, Mark Good, Ian Yacht, people at Elements.cloud. This is GPT Dreamin'. I look forward to this every year, every time you put it on. And let's just keep this conversation going. Thank you very much.